Hello, my dear students. This is Matt Duck. So, during this session, I'm mainly focused on finding area and volume bounded by a curve. Area bounded by a curve, and when that function rotates about x-axis, how to find its area. So, integration, by using integration, we can find area and volume. So, there's specific method. There's specific method. Let's do. So, you consider y equal fx is a function. Y equal fx is a function. So if you consider a region A to B, here area bounded by the curve and the x-axis. A to B is not a fixed value, no? It has variable areas when you consider. So from here to here, you take variable x, then give a small increment dx, then corresponding small this tiny part, it is like a rectangle. You can consider that one as a rectangle. If that one very small, then you can say that is a rectangle. So here we say y is a function fx, then this coordinate will be y, therefore this height will be y, therefore area of the small tiny part we say dA, y times dx. You consider this one as a rectangle. Okay, then dA equal y times dx. So if you add such objects from here to here, A to B, you can get full bounded area. So that addition we say integration, definite integral. So A to B dA, we call A to B y dx. That is equal the area bounded by this curve. Area bounded by this curve. Therefore, right side, we know y is a fx. Therefore, when we integrate a function from A to B dx, that represent bounded area. Bounded area. That is the fundamental definition of area. But if this function in fourth quadrant, then this answer can be negative. Then later we will discuss that. But anyhow, you remember A to B fx dx, usually that represent area. Okay. Then you consider this y equal fx function gonna rotate about the x-axis. That gonna rotate about the x-axis. And also we can rotate that one about y-axis as well. But anyway, I'm going to consider the thing about rotating about x-axis. About x-axis. So now similarly, you take x, then small increment dx, then corresponding value y, then you rotate it. Then we can make a disk here. This is a disk. Its radius y, this height we call radius, no? Radius y, and the small tiny part, the thickness, we say dx. So along the x-axis, we put dx. Okay. Now, for the small tiny part, it's like a cylinder. Then cylinder area pi y square times dx. Pi y square times dx. That is area of the small cylinder. So if you add such cylinders from A to B, we can create full body volume. Therefore, that thing we can do using integration. You put A to B dV, right side A to B pi y square dx. This represent the required volume. So here the volume. Then you can take pi outside. Instead of y, you say fx. Then remember, pi A to B fx square dx represent volume bounded by this rotation, rotation of the function. So you better remember these relations directly, because definitely this thing you can apply directly. Okay, now let's move a little further. Let's move a little further. Okay, see this and all? See this and all? Now, I told you there can be different magnitude for area, that can be positive, that can be negative, because of this relation. Because integration result represent positive values, negative values, and zero values. Therefore, let's see how to find exactly area. So you consider the function. If that function stay like this, then this area you say A to B fx dx. That represent this area. Here A, be a y equal fx function. So with a function like this, here AB, so if you need to find this area, this function fx, you write here a to b fx, but that is in fourth quadrant, no? Then you need to put modulus to get that area. Use modulus sign because we get result negative value. So if you consider a relation like this, take this function here a and here b, let's say here c. If you need to find this area, then same function fx, you need to integrate separately for different regions. So now you get a to c fx dx, then c to b fx dx. Don't do at once. You need to do separately. Now a to c, area negative, you put modulus sign. Then c to b, area positive, no need to put modulus sign. Then this will be area. That will be area. So another thing, see this one. You consider two functions, x-axis, y-axis. Consider two functions. So here fx, here gx, fx, gx. Then if you need to get this bounded area between two functions, okay, you can do this way. Then upper function fx, below function gx. Then you get first bigger area, then get small area. Then you do at once integral a to b fx minus gx dx. But if you don't know where the bigger one, then you can take modulus sign. So if we know the graph, then we can select that one. But if you can't sketch the function, then you better to put modulus sign. So if we do that notation, fx minus gx dx a to b, put modulus sign. Then fx minus gx okay, and gx minus fx also okay. So that relation very important. You can find area bounded by the curve between two curves, and also you can find area bounded by the curve and the x-axis. That relation very important. So when we rotate the function, then by integration you can find its volume. It's very simple thing. So if you know integration, then you can easily find area, volume, and also there are more applications. Thank you for watching us.